When it comes to infrastructure code, we usually try our best to minimize the amount of code rewrites to create multiple set of infrastructure resources. Today, we will explore some examples on how to use count and for each in Terraform to achieve exactly this use case and also understand the implications and effects to actual infrastructure resources. If you're new here, I'm George and you're on Pablo Spot, a space where I show and tell things and practical examples around DevOps and cloud technology in general. Having said that, let's get straight to it. Let's start coding. For a very simple example, let's say I have a requirement to create 4 ECS clusters. And so my very basic approach would be to create 4 different resource blocks for my infrastructure resource. So on my main.tf, the basic setup to create 4 different ECS clusters is to start with one resource block. Inside this resource, I will add a name property and call it cluster1. If I want to create 4 clusters and show this explicitly inside my code, I would copy this resource block and create 3 more copies. And then I will need to update the arbitrary resource names on each to make sure that the names don't clash. Otherwise, Terraform will complain about this and it will fail. I will also update the name property on each of the resource block to indicate the name of the cluster. Before I start spinning up the actual infrastructure, let's have a look at how my backend.tf looks. I store all my Terraform state files in Terraform Cloud, which is why I use remote as backend in this file. But I need to update this further to make sure that I have the right configuration. So let's update the organization accordingly. And the workspaces block. Now let's go ahead and create these 4 clusters. So let me head to my VS Code terminal and prepare for the run. I will first export my TF workspace environment variable and then export TF workspace prefix environment variable for my workspace setup. And then I'm going to run my script to create my workspace in Terraform Cloud. The next thing I will do is set my AWS credentials on this session by running AWS Vault. And then run Terraform init. Terraform plan. And then the Terraform apply to spin up the infrastructure. What I'm going to do now is switch to my browser and then head to my AWS Web Console. And let's go to ECS. And I can see the 4 clusters in the list. Now let me switch back to my code. And on this terminal, I'm going to fetch a list of all Terraform resources that have been created. So I will run Terraform state list. Notice that the list of resources here are in plain strings separated by dots, which is the simplest form or structure the resources are set and managed by Terraform. Now let me go back to my code. Obviously, my code is not in its best structure or form. If I need more clusters on my infrastructure down the line, I will have to add another resource block on my code and it will become longer and longer. And as you start dealing with more complex and additional resources, this approach will be very difficult to manage and even read. And so to refactor my code, I will need to introduce the count property inside my first resource block to allow for Terraform to loop through the code X number of times to create my infrastructure resources. So what I will do is head to the first block, which is right here. And I will add a count property. And because I need to create 4 resources, I will set the value of this property to 4. I need to change the way I set the name property, otherwise I will have 4 clusters with the same name and Terraform will complain about it. So what I will do is fetch the current count index and append that to a string. And so my name property will look like this. Note that count starts from index 0. So if I want my cluster name to start from 1, I will need to add 1 on my count.index. And now I can get rid of the rest of the code inside my main.tf. And my code now looks a lot simpler and easier to read. Now, if I head to my VS Code terminal and start updating my infrastructure, so I'll start by running Terraform plan. If we quickly inspect the result of the plan, notice that the plan result shows 3 resources to be created and 3 resources to be destroyed. And this is because I have changed the structure of my resources, which I will show you later. So let me go ahead and apply this. And now, if I switch to my browser and refresh this page, my ECS clusters are there. It may not seem like nothing has changed, but 3 of these resources are new. These 3 clusters that we saw earlier have been destroyed prior to creating a new set. Now let me switch back to my code. And if I run Terraform state list, notice the new structure of the resources in the list. They now contain indices, and this is because I've changed them from a basic structure to a list structure. This is what the count property allows us to do in Terraform. Now let me go back to my code. When using count to create complex resource structures, I can also pass a list and use the length of that list as the value for the count. So I'm going to create a list that contains all the names that I want to assign to the clusters. So what I'm going to do is head to my locals.tf and then define that local parameter, call it cluster names. And then back to my main.tf. I will get the length of the cluster name's local parameter and assign it to my count property. And then to set the name property, I will fetch the value from the cluster names list based on the count index. So it will look like this. What I'm going to do next is head to my VS Code terminal and attempt to update my infrastructure. So I'm going to start running Terraform plan. Notice that Terraform did not find any changes to the infrastructure, and this is because all the properties are still intact. Now let me head back to my code. This setup is quite common when trying to set up multiple versions of a resource, but this has a problem. Let me head to my locals.tf. And suppose I don't want cluster 1 to be created, so I'll get rid of that from the list. And then head to my VS Code terminal and rerun Terraform plan. Notice that the result of the plan shows 4 resources to be destroyed and then 3 will be created. But that is not what I want to happen. I only want to get rid of 1 cluster. And so I'm seeing an unintended set of changes in here. Now let me go back to my locals.tf and reinstate cluster 1. And what I will do is reshuffle these names Now that my cluster names have been reshuffled, let me head to my VS Code terminal and run Terraform plan. Notice that the plan result shows that all 4 original resources will be destroyed and a new set of clusters will be created. This is because Terraform found changes to the cluster name properties on each of the elements in the list. If this is an actual infrastructure, what this means is that you may be destroying existing resources that are currently used in production, which is a very scary situation. Although technically, You have not added or removed any new cluster names in the list. The resources are replaced and may result to unintended consequences on your infrastructure. But we have a solution for this. So let me head back to my code. So by now, we would have realized that the count property in each resource allows us to create a list of infrastructure resources, as what we've seen in main.tf. These resources are index-based, as we saw earlier when we ran Terraform state list to see the list of infrastructure resources managed by Terraform. But count is not the only property that allows us to create multiple infrastructure resources out of one single resource code block. I have been using this quite a lot in my previous episodes and series, and this is the for each property. And I find this more powerful and useful than the count property. So what I'm going to do is I'm going to get rid of the count property and add a for each property and assign the value of my local cluster names parameter. The for each property right here does not work with lists of native types like strings or numbers. So what I need to do is convert the list into a set by calling the toSet function. This set now contains a data structure with string elements on the list as the key to each element. And then to assign the right name of the cluster, I will use the each property derived from for each and use the key property so that the name property will look like this. And now, if I head to my VS Code terminal and then rerun Terraform plan, the result now shows 4 resources will be destroyed and 4 new ones will be created. I am expecting this because I have changed my implementation from using count to for each. And before I start running Terraform apply, let's run Terraform state list once again. Keep in mind that the structure in the names of the resources are index-based. So now let's go ahead and apply the changes to the infrastructure. Switch to my browser to verify the resources on my AWS Web Console. So I'm going to refresh this page. And my new clusters are still there. Now, if I go back to my VS Code terminal and rerun Terraform state list once again, notice that the resource structure has now changed to key-based. This means the set of resources that I created is no longer a list that is based on index, but a map based on keys. So now if I go back to my code, and then head to my locals.tf, and this is where it becomes very useful. If I reshuffle the names on this list, and then head back to my VS Code terminal, and then rerun Terraform plan, the result shows that nothing has changed, which is exactly what happened. I just essentially reshuffled the arrangement of the cluster names in my list. This is also because Terraform is comparing resources not based on index, but based on key. This ensures that the change we make is intended for the right resource we want to change. Now let's do one more thing. Let me head back to my locals.tf. And let's say I no longer need cluster 1. So let me go ahead and get rid of that. And then if I head to my VS Code terminal and rerun Terraform plan, notice that the result shows one resource to be destroyed, which is essentially what I want to happen. And this is why for each is a lot more powerful than count. And that's all I have for today. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.